For thousands of years, one number has stood as the crown jewel of mathematics: pi 3.4159, the ratio of a circle's circumference to its diameter. It's etched into pyramids, repeated in physics, and whispered in classrooms like gospel. But what if we've misunderstood the circle itself? This is not just mathematics, this is a philosophical revolution. Today, we dive into the forgotten constant, the geometry of motion, and a perspective so powerful, it may change the way you see the universe. Pi is defined as the ratio of the circumference of a circle to its diameter. But here's a critical question. Why diameter? Why use a measure, diameter, that isn't fundamental to how circles are actually constructed? The radius, not the diameter, is the building block of a circle. With a single fixed radius, you can draw a circle. From planetary orbits to quantum wave functions, the radius is what governs symmetry, oscillation, and balance. So why define a constant around the diameter, a measure that doesn't naturally emerge from the circle's essence? Mathematically, tau, t, is defined as the ratio of the circle's circumference to its radius, t=r. That means 2 equals 2p. At first, that might seem trivial, just a doubling of pi. But this is not cosmetic, this is conceptual. Consider, a full rotation in radians is 2po. That's messy. Why not just say one full circle is 1t? It becomes elegant. A half circle? To 2/4? To 4. The mathematics of symmetry, rotation, and periodic motion becomes seamless. In Euler's identity, pi appears. Eos ip plus 1x 0. A poetic equation. But with tau, e wordt it, il1. Pure unity, a full return to origin, a circle closed. In physics, clarity is not a luxury, it's a necessity. Consider simple harmonic motion, xt x a cos at plf. The angular frequency O is 2pf. Why clutter it with 2p when u equals tef is so much more direct? Wave equations, circular motion, oscillators, all governed by radians per second. And if one full cycle is t, then every formula becomes more aligned with physical experience. Einstein once said, "Make things as simple as possible, but no simpler." Tau is not simpler in computation, but in concept. It represents the full geometry, not half a truth. Let's visualize. A circle drawn with radius r. The full sweep of that radius across the boundary of the circle, one complete cycle, is radians. The unit circle, so fundamental in trigonometry, now breathes more naturally. In calculus, when you integrate over circular paths or evaluate Fourier series, t brings a smoothness. The sine wave is inherently tied to cycles, not diameters. The brain perceives waves, rotations, and periodicities. Nature doesn't speak in diameters, it pulses in cycles. Then why did pi dominate for millennia? History, simplicity, tradition. Pi was easier to measure with strings, wheels, and ancient tools. But like old maps of the world, we now know there's more beyond the horizon. Education clings to what it knows. But true science? It questions even its constants. This isn't just a mathematical argument, it's a mental reprogramming. Pi is familiar, tau is alien, but truth doesn't bow to comfort. Tau challenges our assumptions, and in doing so, frees our minds to see patterns more clearly. This is about perception, precision, perspective, and perhaps letting go of a number we love to embrace a constant that reflects the circle's soul. So, is pi wrong? No. But maybe it's incomplete. Tau invites us to rethink not just how we do math, but how we think about the universe. A circle isn't half a truth, it's whole. It's unified, it's T. And maybe, just maybe, that's the clarity we've been searching for all along.